Bismillahirrahmanirrahim. So today in this video we'll be learning about the rapid drawdown analysis using the slide software. Firstly, we'll come to know that what basically rapid drawdown analysis is. Look, this is the reservoir level of the dam. If the water drops to this level, it means the water has been dropped rapidly from this point to this point, and it will definitely affect the stability of this slope, because this ponding water provides some kind of support to this slope. So once this level is down, when this drawdown happens, there will be effect on the stability of the slope. So this is what we call a rapid drawdown analysis. There is another scenario as well. The water level can drop to the different stages. For example, if water level drop to this height, then obviously there will be effect on the stability of slope, but it will be less than the total rapid drawdown. So we can perform the multi-stage rapid drawdown analysis. Multi-stage rapid drawdown analysis means that the drawdown happens in stages. For example, after 10 days the water level is down to this point, then after 2 days it is down to this level, and this is how it is called multi-stage rapid drawdown analysis. So what we will do in this video lecture, firstly we'll analyze the stability of this slope without drawdown. Then in the second case we will consider the rapid drawdown and we'll check the stability of the slope. Then in the third scenario we'll check the multi-stage drawdown and we'll check the stability of the slope. So let's come back to the slide software. This is the slide software, and these are the coordinates to model this geometry. So let's start with the slide software. Firstly, we'll go to the analysis, we'll go to the project setting, as these things have already been discussed. Now look, here I will select left to right. Why left to right? Because I want to analyze the stability of this slope. So failure direction will be from this to this direction. So which is left to right. Okay. Now left to right. Rest of the things will be same. Now methods, I can select different methods. I have explained all these things already in the previous videos. So those who haven't gone through the previous videos, please go through the previous videos to understand this video lecture properly. So I will request you all to please watch the video online rather than downloading, and you can also join our Facebook page with the same name as my channel. There we will be having some free learning programs regarding the laboratory testing, software, etc. So now we will go to groundwater. As in the first case, we will be analyzing a simple case. We are not considering the rapid drawdown. So that is why I will not change anything here. We'll click OK. Now I will go to the boundary, add external boundary. We'll go to here to add the coordinates. Now I will go to this file. So firstly I will have to select external boundary. So I will select this, Control C, and we'll just paste over here, Control V. So you can see the external boundary is drawn. So the next thing is this is the embankment, and this is the external boundary. It is the hard bottom or foundation, you can say. This part is the fill material, granular fill material. This is the transition part of the dam or embankment, and this is clay core. So now in the next step I will be modeling the this bottom or foundation. So these are the coordinates of the foundation. I will be just copy, Control C, then I will go to, now remember anything you want to define inside the external boundary, you will have to select material boundaries, add material boundary. Now we'll go to the coordinates and we'll do Control V, and you can see the right click, done. Oh, sorry, by mistake. Control V again. Now you will have to do right click and done over here. Now the bottom is defined. The next step is to define the transition zone. So I will be selecting these coordinates. These are the transition coordinates. Control C. I'll be uploading this document file in the description. You can download and practice as well. Control C, and then again I will go to material boundaries, to the coordinates, Control V, and you can see the transition is the model transition phase. Now I have to define the clay core. So again I will go to this document, and these are the coordinates of the core. I will select all these coordinates, Control C, and now I will go to the boundaries, add material boundaries, we'll select the coordinates, Control V. Okay, the core is defined now. The next step is to define the material. So I will select the material, define material. Firstly, I will be defining the material of you can say clay core. Now the material properties are given in this file. You can check the material properties of core are given over here. Unit weight is 20 kilonewton per meter cube, cohesion is 20 kPa, and friction angle is 20 degrees. So it's 20, this one is 20, this one is 20. Now click OK. Sorry, we will go again. This is clay core. The next material is transition material. Yes, now we'll select the properties. What are the properties of transition? 20 unit weight, 40 cohesion, 22 friction. 20, 40 is the cohesion, 22 is the angle. Yes, so this is defined. Now granular fill, the third material is granular fill, and the properties are given in this file. Granular fill material properties are given over here. Unit weight is 21.5. Cohesion is 0 due to granular non-cohesive material. 40 is the friction angle. 21.5. Cohesion is 0, and 40 is the angle of internal friction. Now the fourth material is bottom, hard bottom. You can say hard bottom, and the material properties are given over here. Foundation properties, unit weight is 24, 200 is the cohesion. Unit weight is 24, 200 is the cohesion, and the and 45 is the friction angle. So here 45 is the friction angle. So now I will have to assign the properties. Yes, clay core here. This is transition zone. Okay. This one is transition zone. Next one is granular fill material. So granular fill has been assigned. Then the hard bottom, click this one. Okay, now clay core is select this one. So this is how we have defined the materials and assigned as well. The next step is to provide the reservoir level or phatic surface. So for that purposes we have these coordinates. Now I will go to the boundaries and we'll click add water table. Now I can apply manually as well as by coordinate system. So what I will do, I will just copy these coordinates, Control C, and we'll paste over here, click OK and done. Right click and done. No, it says do you want water to apply to all the materials? Exactly, it is applicable to all the materials. You can say the granular fill, transition and clay core and foundation. So we'll be clicking OK. Now the reservoir level is defined. The next step is the last step is to define the water the surfaces. Auto grade, okay, yes, the purpose is already defined. Why we apply this, you can watch the previous video. I will click show grid option, done. Now we'll compute the factor of safety for the first case. So now we will check what is the factor of safety without the drawdown. In the next case, we will study or check the change in factor of safety due to the rapid drawdown. So you can see it's 1.928 according to Bishop simplified method. According to Jumbo method, it is 1.772. Now we will move on towards our regional project. Now we will go to the setting and we'll check the how we basically do the rapid drawdown analysis. It is we will move to groundwater analysis. We'll click advanced. Here we will check the rapid drawdown. Now we want to check the effective stress using DBAR method. DBAR method is related to the generation of pore water pressure due to the application of stress in undrained condition. So that is why I will be selecting this one. Now the next step is I will go to material, define material. Here there is a small change. Look, clay has a very low permeability. So the condition in clay is unsaturated. So that is why I will go to clay and will select undrained condition, undrained condition here. And for rest of the things, I will not make any change. So because all the granular material is drained material, so undrained condition exists in clay soil. That is why I clicked over here. Now in this position, this is initial water content and it considers the rapid drawdown to the 0 level in this case. So let's check what is the factor of safety after the drawdown. You can see it is the initial water content. You can define the multi-stage rapid drawdown as well. We will check in few minutes as well. Now we will go to compute, interpret, and here you can see the change in factor of safety 1.677 from 1.922. This is the effect of rapid drawdown because the water level is dropped from this to this level in this case. So if we check according to Jumbo method, it is further reduced to 1.527. So this is how we can analyze the effect of rapid drawdown. So you can also simulate or correlate this behavior with rainfall as well. But I will recommend you, those who are simulating the effect of rainfall on slope stability, they can check my previous videos that is related to the transient groundwater analysis. So the detail is given over here. You can simulate the infiltration rate with the passage of time. You can in the transient groundwater analysis, you can check how much water has been seeped in 1 day or half day or 3 days. It means most of the people were asking about the rainfall simulations, so you can do the simulations through indirectly through transient groundwater analysis. I have uploaded that video with the very detail. So now I will go to modeler to define the multi-stage rapid drawdown. Let's say I want go to add drawdown line. I want the drawdown line to be, let's say, from this point to let's say I want the drawdown to this level. Okay, you can do this. Now the water is dropped from this to this, and I want to check how much factor of safety is changed. Interpret. So here you can see factor of safety is changed to this level 1.322. Why? Because water has support to the slope, the ponded water. So you can check the from the jumbo method. So this is how you can analyze the multi-stage rapid drawdown. You can vary these locations and so on. So thank you. I hope you like the video. If you like the video, don't forget to subscribe